In the previous unit, you learned about robot manipulators. So this is like the mechanical arm. But in its wider conception, a robot also has a mobile part. So in this unit, we will learn about mobile robots. And when we speak about locomotion and mobility, basically we have two types of apparatus. One could be the use of wheels, and we speak about wheeled robot. Also, we can have legs, like we can have a biped, we can have a quadruped, we can have like multiped robots, also which are inspired by the motion of the hexapod like insects. And locomotion could also be a sort of combination. You can have a leg and a feet, but also you can achieve mobility by some kind of crawlers, like to move on a sort of uneven terrain. Let's concentrate on wheel mobile robots, which by always are the most diffused type of mobile robots. In a wheel robot, we have two main components. One is the base, which is also called the chassis of the robot, and then we have the wheels. And clearly, the base is quite standard, it's quite ordinary. There's not much to say about the base, about the chassis. Whereas we can have three types of conventional wheels which are used. The simplest type is the fixed wheel, in which there is basically, this is the wheel, and there's one rotation axis about the plane of the wheel. But also we can have a steerable wheel, where besides the rotation orthogonal to the plane of the wheel, we also have the possibility of steer the wheel and just to change the orientation. And there is a third type of steerable wheel, which is known in the literature as a caster wheel, where the difference is the presence of an offset between the axis of the steerable axis and the rotation axis. So these are the three types of conventional wheels which are found in mobile robots. Let's take a look at how we can mechanically arrange those wheels in different designs. Clearly, two wheels is not enough, and in fact takes years to a child to learn how to bike without supporting wheels. So when we speak about multiple wheels, we can identify a differential drive mobile robot vehicle in which we have one front wheel, which is of caster type, and two rear wheels, which are of fixer type. Then we can have the so-called synchro drive mobile robot, in which three steerable wheels are used, and there is also sort of kinematic coupling, thanks to which only two motors are implied to move the three wheels in a synchronous way, as the name itself of the robot suggests. And then we have the tricycle, which is used by the kids. Before learning how to bike, a kid is learning with the supporting wheel. So the tricycle has one steerable wheel in front and two fixed wheels on the back. Now, I was born in Naples, and I learned to drive in Naples. And I remember when I was a PhD student, I went to Georgia Tech in Atlanta, Georgia. And the first time I was allowed by my mentor there to borrow his car and say, can you drive? Do you have a driver's license? My answer was, not only do I have a driver's license, but I usually drive in Naples. He didn't quite understand what I meant. Then a year later, he came to Naples, and he did understand what I meant. And the art of parking, of doing a parallel parking in Naples, where you have a very narrow spot, and clearly you can't move the car in this kind of transversal direction to park. But any Napoleon driver is able, maybe in one and a half maneuver, to park the car. So in a car-like robot, we have four wheels, clearly. Typically, we have two steerable wheels and two fixed wheels. And this does not restrict the mobility, because to park, for instance, as you will learn in the second part of this course about robotics foundation, we'll be covering mobile robots and motion planning. Nevertheless, you can do some motion and park the car, so the equivalent motion, this can be achieved. So this was a car-like mobile robot, but also if we really want to move in any direction, if we want to be omnidirectional, there is one such design arrangement for a mobile robot, and this is known as the omnidirectional robot, in which basically to get the widest mobility, we have three equally spaced caster wheels in such a way that we can move in every direction. And speaking about the wheel itself, there is also a very keen design, which is known as a mecanum wheel or Swedish wheel, which are some kind of rollers which are mounted at 45-degree angle, with respect to one another. And in this kind of platform, we can really, as the movement of the rollers provide the actuation of the wheel, we can move also horizontally and vertically. So we have omnidirectionality in the widest sense. How do we characterize the features of mobile robots? Clearly, the most important feature is balance. I mean, a two-wheel robot is unlikely to work unless the driver is skilled, to ride a bike. So static balance is of concern, and typically there is a triangle formed by the 3 points of contact of the wheels to the ground, and the center of the mass of the system must fall within this triangle. So if we move for instance, from 3 wheels to 4 wheels, we have a square, we have a polygon, and in this way static balance is a sort of alleviated because we can statically balance the system, the vehicle, in a kind of easier fashion. And not only balance, but also workspace. Workspace is another feature which is characterizing the mobile robots. And clearly we can state that workspace is infinite because with a mobile robot we can really move everywhere, but there are some constraints, and we will learn about these constraints on the motion in the second part course when we're speaking about the mobility and the motion planning. To conclude, we can take the advantage of a mechanical arm which is devoted to manipulate objects, and we can think about mounting a manipulator arm on a mobile base. Clearly, the control and the programming of the motion for this system becomes more complex because we will learn this concept, we will formalize this concept into the study of kinematics. This is the concept of redundancy, because you have more degrees of freedom than those that you need to position and orientate an object in space. So not only do you have to control the motion of the vehicle, of the base, but also, and the wheels of course, but also you have to control the degrees of freedom of the arm. And you want to do this in a kind of coordinated fashion. Why are these mobile manipulators used for some kind, especially relating to the previous unit, for field applications? Because they are provided with sensors. And with the sensors on board, the vehicle and the arm, they are capable to interact autonomously or partially autonomous with the environment and to provide a more reactive behavior and ultimately execute the task of the mission that they were designed for.